welcome to SVM, support vector machine in Python. So here I have imported some libraries, pandas, numpy, cbon, and matplotlib. And let's go ahead and grab and get the data set. So today we are going to use the built-in data set, which is related to breast cancer. Okay, so that is a scikit built-in data set. So from sklearn.datasets, we can import the data set. Load underscore breast cancer. Okay, and then I'm gonna instantiate this breast cancer data set and pass that to my variable called cancer. Okay, and we can explore the data set a little bit by taking a look of the keys. Okay, there we go. So what we have here is the data, the target names. If you want to take a little bit closer to the data set, you can take a look of the DESCR, the description of the data set. And also we have feature names and the file name. So let's take a look of the detailed description. So cancer, let's print that out. Cancer, square brackets, DSCR. Okay. So what we have here is there is 569 instances, okay, with 30 numerical attributes, and the prediction that you want to do is whether or not the tumor for this breast cancer is malignant or benign. Okay, and you have a bunch of different data points, say the attributes here, the smoothness, the compactness, okay, the area, etc. We're going to go ahead and set up a data frame using these keys to actually grab this data. I'm going to say df underscore feat, okay, equal to pandas library data frame, and let's pass in the data. So cancer data, and then the column name. Let's set that the columns will be the feature columns, right? So in this case will be feature names. Cancer, square brackets, passing feature names. Okay, so let's take a look of the data frame. So df underscore feed.head, and let's take a look at the first two rows. So there we go. And also you can go ahead to check the info. Okay. The info, right? And we got 30 columns here. And if you want to see what they reference, you can go to the target names, and you can see the reference is malignant or benign, right? So cancer target. Okay, basically this is the number array with 0 or 1, right? And let's go ahead and do some exploratory data analysis. If you want to explore the data, you can go ahead and do anything you want with cbon or matplotlib. But we'll actually skip this officially. I do want you to explore the data using some sort of visualization, but since so many features here are actually hard to interpret, such as mean smoothness, worse perimeter unless you have an actual domain experience in cancer research and how tumors actually work and what they look like and how you actually gonna diagnose cancer, right? A lot of visualization will be lost because you're not going to be able to interpret the results of something like mean area versus mean smoothness. What does that mean, right? So we're gonna just go ahead and let you do whatever visualizations you feel comfortable doing, but I suggest to skip this and move forward to train test split, okay, which focus on actually running the machine learning algorithm, the machine learning model. But again, I still encourage you to do some kind of exploration on the data that looks interesting to you. Okay, let's go ahead and go to train test split. And we know that from sklearn dot cross validation input train test split no module. Oh, if you have the similar situation with mine, you can replace the cross validation with model selection. Should be good. Yeah. Okay. And also I'm gonna shift tab to read the documentation as usual. Go find example. In so this one, copy paste, put it here. Right. Okay. I'll set the text size to be 0.3, and also the random state, my favorite number, 101. But don't forget about to setting up your x and y, right? So what is x? X should be your feature columns, right? So df feet, and y is the target class. Easy. So run this. So now we have our data split. So let's go ahead and train the support vector classifier and actually grab the support vector classifier model. Okay, so you will go ahead from sklearn dot SVM and import SVC. So here is we have capital S, capital V, and capital C. Okay, and then we gonna have a instance for SVC. So let's pass that to the model variable, and instantiate this SVC helper function. Okay, and fit this model to my training data. Y train. Okay, perfect. So X train, Y train, this is just what we have done for a bunch of other times, right? So now something to note here is that you'll notice here that's quite a few parameters, such as the gamma, such as C, or the you can see the kernel equal to RBF. We're going to take a look at these later on, but for now, let's go ahead and just do the prediction using the default values and see how that works for us. So I will say predictions is equal to model dot predict, and let's pass the testing data. Okay. And then from sklearn dot matrix, let's input classification report and confusion matrix. And let's print the result. So print confusion matrix, y test, and also the prediction, and print a new line. Then let's print classification report, and also with y test and my prediction. Okay, so let's run this. And we see something really interesting occur, right? Basically what happened is this model of default values predicted that no tumors were in the 0 class, right? You will actually get a warning here, okay? The scikit-learn, it will warn you that prediction and the precision and F-score, they are EU defined and being set to 0.0 in labels with no predicted samples. And you see that from the confusion matrix as well, right? It's basically predicted everything belongs to class 1. So now the reason that is happening is that we are classifying everything into a single class, is because our model needs to have its parameters adjusted. And it may also help to actually normalize the data as well. So when you're passing it into a support vector machine, where we can just go ahead and do is search for the best parameters by using a grid search. And the grid search will allow you to find the right parameter, such as like what C should be, what the gamma value should be, and finding those right parameters is usually a tricky task. But luckily, we can be a little lazy and just try a bunch of combinations to see what works the best. And the idea of creating a grid of parameters is trying out all the best possible combinations. It's called a grid search. Okay, we'll talk about this method in the second part.